founder and co-owner of Aquatic Sports Performance. Today we're going to be talking about how we use velocity-based training. I'm going to do a little bit more of these kind of short presentations. I know people are busy and they want to learn something real fast, so I'm going to try to keep this under 10 minutes today and just talk about velocity-based training. So this presentation is going to be about how we use it at our facility. I know there's a lot of other methods you can explore. Some resources you can check out are Jacob Tober, the VBT coach. Dr. Brian Mann has great information on it. Also, Travis Mash from Mash Elite Performance, he's put out great content on it. So there are different methods you can use and play with for velocity-based training, but this presentation is going to be about how we use it at our facility. So today's topic outline, number one is quantify intent. Number two, track progress. Three, neutral third-party coach. And then number four is some things I've changed my mind on in terms of velocity zones and how I intend to improve it in the future. So quantify intent, this is probably one of the greatest reasons why we use a linear encoder, which is just a device that measures velocity. It gives athletes immediate feedback on how much effort they put into a lift, regardless of the load. So we try to get athletes to move weights fast, no matter if it's a warm-up, work set, whatever it is. We try to get them to move it as fast as they can. And the reason being is it helps make any training program more athletic. And what I mean by that is if we take the power formula, so if power is force times velocity, and you know the force, which is basically load, if that's predetermined, the only thing we really have control over is the velocity part. And so if we take, let's say a work set is something like 135 pounds or 60 kilos, and then 185 pounds, which is I think 70 something kilos, and then 225, which is 102 kilos. Let's say athlete A moves, all the loads at a moderate level, then the total power that they produced, or the average total power that they produce is going to be less than someone who tried to move all the loads quickly. And so if you think about it that way, in terms of power equals load times velocity, and we're just constantly trying to increase the velocity side of things, athletes tend to gain strength and power quicker. There are some research studies that have shown this, but also it just makes common sense too. If you've ever watched an athlete lift slowly versus an athlete lift quickly, the athlete lifting quicker just looks more athletic. And the cool thing about this kind of training is athletes, they can watch in real time. So let's say they're warming up with 135 pounds, which is 60 kilograms. And they kind of half-ass the first rep, and they immediately get feedback. Oh, I wasn't giving enough effort on that. Let's try a little bit harder. And you'll see that when you coach athletes, when you kind of gamify it for them and they want to put more effort in. This is one of those studies I was talking about earlier. I won't go into it. I'm just putting it up here because I know people will ask, but this is a meta-analysis, which is basically a study of studies, kind of showed the benefits of lifting quickly. This was another cool study that they did on older women, Fielding et al. They had two groups. The first group, they lifted 70% of their warm rep max with maximum intent, meaning they lifted it as quickly as they can. And then group two, they were just told to lift. They used the knee extension and leg press for this exercise, or for this study. But what they found was that they found significant power increases in group one. And those are the values, 267 watts versus 139 watts. The second reason we use it is to track progress. So there's many ways you can track progress using velocity-based training, but one of the primary ones that we test is the back squat and trap bar velocity test. And this is kind of our safer alternative to one rep max, the traditional one rep max testing. So you can use it with other exercises. You can use it with the seal row. You can use it with the chin up, and you can actually test week to week. But just with how the logistics work at our facility, We have a lot of athletes coming in, and it's kind of a logistical nightmare to test every single athlete every single week. So we just do the trap bar deadlift and back squat, and we have them deadlift or squat 1.25 times their body weight as quickly as they can. And the reason we pick 1.25 times body weight is, one, it's relative to their body weight. So as the athlete gets older or they get heavier, it's still relative to the body weight. And then also, it's heavy enough to be somewhat close to maximal strength for high school athletes, but it's also light enough to be safe. I think 1.5 times would be a little bit too heavy, where we start risking injuries. And but then 1 times body weight would be way too light. And so I kind of played with a bunch of different ones, but 1.25 kind of seems to be the safe spot. And in regards to how we select who does back squat and who does trap bar deadlift, we go back squat for water polo and breaststroke athletes, just because the knee flexion range of motion is similar for the egg beater and breaststroke kick. And then everyone else basically does trap bar deadlift. Couple things before we have anyone do this test, we always make sure that the athlete has the capacity to squat and deadlift with great technique. So we have a whole progression system. I can make another video on that whole progression system later, but we make sure they've gone through that progression system. They can do it with great technique, and they have the capacity to lift way greater than 1.25 times body weight. So, let's say if their 1 rep max is 1.24 times or 1.25 times body weight, I'm not letting them do this test yet. I'll probably have them get up to at least 1.4, 1.5, 1.6, somewhere in there before we do this test. And one of the ideas behind this is, if the meters per second improves at a given load, which is the relative load, maximal strength and power most likely also improves. And also, not only maximal strength, but that speed is typically closer to the speed that the athletes will use in sport. No one's actually moving at a speed that is at maximal strength. So maximal strength speed is very slow. So if you look at the force velocity curve and you go to the right, velocity is slower. That velocity typically doesn't happen in sport. So that's one of the reasons why we use this as our air quotes strength measurement. I pulled some normative data from our data set. A couple things to keep in mind. We coach mostly high school athletes, so most of this data is from high school athletes. We have a handful of middle school athletes,